So let's actually continue. You see that it's so you're going to have this graph on your notes, but it won't just be, you see that it's every point that is on this graph we can actually interpret, okay? So now this we have said for the increasing returns to scale portion. Now let's come to this, okay? Now let's come to, you can actually think that there's actually this kind of a flat portion there, okay? So that is the place where we have constant returns to scale, okay? Then this short-run average cost curve, suppose K1 is the optimal amount of capital in order to produce Q1, okay? Q1 level of output. And then at this point, it's going to, the short-run average cost curve is going to touch the long-run average cost curve at its minimum, okay? Because there is the, so if you can, suppose there is constant returns to scale, okay, on this portion, and this is the long-run average cost curve. And what can I say actually about the short-run average cost curves? The short-run average cost curve and the long-run average cost curve. Remember, what did we say? Long-run total cost curve is an envelope of short-run total cost curves, meaning that all the short-run total cost curves are above the long-run total cost curve, right? Now, if it's for the averages, what should I say? It's similar, right? So the short-run average cost curves should always lie above the long-run average cost curve, okay? Then, if I have constant returns to scale, which means that I have a flat long-run average cost curve, okay? Then, if I have a short-run average cost curve like this, if it's going to touch this long-run average cost curve, it has to touch it at its minimum, right? It has to touch it at its minimum. Because if it doesn't touch this one at its minimum, let's say, can a case like this possible? Suppose, can it go below? No, we said that all the short-run curves should be above, right? So there's no way it can go below that. So the only way it can be tangent, right, to the short-run average cost curve is that it's going to be tangent at its minimum, okay? But this is for the constant returns to scale portion of it, okay? Now, that we know, and what else I can say? Now, let me think of the marginal cost curve. How shall I draw the marginal cost curve? Marginal cost curve should go through where? So you said again, Hocam, it has to go through the minimum of the short-run average cost curve. So it has to go through here. And it has to be also, right, cut the long-run marginal cost curve, right, exactly at Q1 level. So that's why it's going to go, so let's draw it something like this, let's say, okay, short-run marginal cost K1, okay? So what's happening here? So the previous case was, okay, interesting, but not as interesting as this one. What's happening here? At Q1, right, at this level, what's happening?
It's the intersection of all
four curves, right? So you see, and what is special about Q1? Q1 is not just any point, but it is a particular point. What is it? It's the minimum of the long-run average cost curve, right? So we know that it's the minimum of the long-run average cost curve. Okay, long-run marginal cost should go through that one. That we know, okay? But now what we learned now, right, in addition to that, we learned that because it's a place where we can actually say that there's constant returns to scale, okay? Or you can think of it because it's the minimum of the long-run average cost curve, right, that we have. If you want to think of it from there, it's the minimum. Then the short-run average cost curve should be, we know that it should be above. But how can that be above? It has to touch it at its minimum because it cannot go below this, right? So it's going to touch at its minimum to right? So the short-run average cost curve is going to touch the long-run average cost curve at its minimum, right? And because it's the minimum, we know that the short-run marginal cost should pass through there. So that's why all four curves are actually intersecting, okay? So let me write this. This is going to be an important point because you're going to see that when we see long-run decision of a firm, you're going to see that, and especially for a price taker firm, for a perfectly competitive firm, when they are actually dealing with their long-run decision, you'll see that that point is going to be very important, okay? So that's why all these production functions, cost curves, all of them would be very important. And you should know, where these things, bless you, where these things happen, okay? So let me write this down again so that you would have nice notes. So this is second. So we said that suppose to produce Q1, okay? So this is Q. So let's say K1 is the optimal amount of capital. Okay, this is the cost minimizing amount of capital that we know. So then we said that fine, it's the optimal amount of capital. So we said that long run average cost and long run marginal cost. So let's put it like this. So basically, let me put it like this. At Q, so we show it like this. Q minimum average, or let's put it long run average cost. Okay, this is the Q that minimizes the long run average cost, and in our graph it is Q1, right? So here we called it Q1. So what's happening? You said that, hocam, because it's the minimum of the long run average cost is equal to long run marginal cost, right? This we know. Average cost is equal to long run marginal cost. And then we also said that, hocam, also this is a particular point where, because Q1 and K1 is exactly the optimal amount to produce Q1, we know that short run average cost is also equal to the long run average cost, right? Because it has to touch it at its minimum point as well. Because it's touching at its minimum point, this is also equal to short run marginal cost. So all these guys are equal to each other, okay? So that's why we have this. So you'll see that this is going to be very important, okay? So, right, so this is actually, you'll see that later we're going to use this, okay? If we have, so like suppose here we only had a single point, but suppose you had constant returns to scale, suppose you had an long run average cost curve like this, okay? So here average cost, here it's Q. So you see that in this portion you have constant returns to scale. As long as you have constant returns to scale, all the short run curves would be tangent at their minimum, okay? So you see all of these guys are, so here in this portion you have constant returns to scale, okay? And these guys, so this is the long run average cost, this is the short run average cost curves, okay? So short run average cost, let's say this is Q0, K0, short run average cost Q1, whatever, okay? So these guys are, or if you want, I can call it Q bar, Q double prime, K prime, K double prime, okay? So you see that all these guys are going to touch at their minimums, okay? So just keep this in your mind when you have constant return scale. Here I didn't draw a flat portion, but I could have. So then that's going to be the case, okay? Now, what about this portion? Now I think you can guess. So this is important, as we said. Now what's going to happen on this decreasing returns to scale portion? Now you guys can guess, I guess. How shall I draw my short-run average cost curve? Let's say I have a level, let's say here, okay, Q2. Suppose K2 is the optimal amount in order to produce Q2. So how shall I draw my average cost curve?
If you tangent to that real point.
Now it's going to be like tangent on which side? This side, minimum, or on the other side, right? So it's going to look like something like this time. Okay? Now it's going to, so let's call this short run average cost K2, okay? And now it's going to be, if you want, you can call it point B, okay? Now it's going to be on this sort of increasing portion, okay? So let's write this down. So the third one, suppose to produce Q2, okay? Now K2, I'm not writing it, but now you guys can. K2 is the optimal level, right? K2 is the optimal level. And then we know that short run, so we can say that long run average cost is equal to short run average cost K2 at Q2, okay? And it is on the increasing portion of short run average cost K2, okay? It's on this side. Now you can again say the same thing. Hocam, it's due to decreasing returns to scale. Because things are, you know, when you expand, things are getting worse. So you can, if you decrease your quantity, you can actually achieve a little bit lower cost. But on your short run curve, right, if you decrease your output, but even a lower cost is possible, right, if you can re-optimize, right, if you can change your capital amount, okay? So that is basically the case. Again, if I need to draw my marginal cost curve, where I should draw this, if I want to draw my marginal cost, what should I do? My marginal cost curve, short-run marginal cost curve, will pass through where? The minimum. So it's going to go through right here, this guy, right? Minimum of the short-run average cost curve. And it should intersect marginal cost at this Q2 level, right? So let's do that. That's going to be hard. So let's do it. So it's going to be it will pass through here. And then you see that these blue and green ones would intersect at this point, okay? So let's go up, let's cheat. Right? So you see they would be equal to each other. They should intersect at this point, okay? So we have learned and we have sort of depicted everything that we have learned, right? All these concepts on a graph, okay? And let me actually write again another reminder that, which I can say the very similar thing. I say that long run average cost curve is an envelope of short run average cost curves. Now this is the new one, okay? And I can always say that short run curves are above the long run curves, okay? In terms of total cost and average cost, okay? So this is the last thing that we have said, okay? Now we're done with the cost minimization, okay? This was it. Did you get this? Right, the figure, I know it's a little bit ugly, but now we know how to draw, right, every single point, right? We know how to interpret every single point. Okay, so may I erase this? Okay. So now we're done with the cost minimization. Now we can come back to our original problem, okay? So we learned everything. We learned the relationship between returns to scale and costs. We learned about the short-run costs, long-run costs, right? We learned the relationship between them. And you're going to see that, of course, they are very important because they appear in the profit function, right? So basically, total revenue minus, we said, total cost. Now, so remember this was total revenue is price times quantity, but we know that price could be a function of the quantity that you would like to produce, okay? And total cost, you said that, hocam, it's a function of wage, R, and Q, the amount that you would like to produce, right? And suppose I give you wage and R, then this is going to be, okay? It's a function of Q, basically. Now, we learned about this part, okay? Now we can get this total cost function, right? If someone tells you, you can get this. We know for any level you would like to produce, what is the minimal cost you can achieve. That we know. We can solve the cost minimization problem and get our total cost function, okay? Now we're going to be dealing with the profit maximization, okay? Bless you. So this is going to be now our new topic, profit maximization. Okay? Now, this is basically, so we dealt with this part. Now let's try to deal with this whole problem. Now we can actually answer this question. Fine, Arçelik, Toyota, Mozart Cafe, Starbucks, they know in order to produce, like a certain level of quantity, how much labor and capital they would like to hire. That they know. What is going to be their cost? They know. Now, how can they decide? How to decide on Q, right? How to produce, how much output to produce. So let's say how much output to produce. They need to decide on that, okay? Now let's try to understand that decision, okay? So we're done with the cost. Now we start with the profit maximization, okay? Because remember here, we said that we're given a Q, right? So we were saying that, oh, given Q0, what is your minimal cost? Fine, we found this and we got this as a function, so which is valid for any possible Q, right? If Q is 1, this is your minimal cost. If Q is 2, this is your minimal cost, right? That we know. Now, we will be dealing with this decision. How much output Toyota, Starbucks, Arçelik would like to produce, okay? Of course, as you said that, hocam, they would like to pick this Q in such a way that it's going to maximize their profits, right? They would like to have as many profits as possible. And that's what they will do, okay? So now let's try to see this profit maximization problem. So the profit function is going to be, suppose you're given wages and R. So this is my profit function, it's going to be a function of what? At least here. So total cost, if I give you wage and R, right? I can plug those values in. It's a function of Q. So there's a Q here, and if this price is a function of Q, we'll come back to this, then this profit function is a function of what? Q, right? So, and then you're going to decide on Q, right? So which is good, right? So now, basically, so this is what we said, firm's objective, right? So we said that it's to maximize profits. But remember, we said that in the very beginning of this course, this is also an assumption, right? The firm's objective was to maximize profits, but remember we said that they could be a manager whose objective is to fly business class, right? Go to nice, instead of Burger King, right? Go to nice restaurants. So remember there was this, what did we call? Do you remember that? It was called which problem? Principal agent problem, right? So this is again an assumption, okay? But now suppose the firm's objective is to maximize profits. Then, so let's see how the firm will act, okay? So basically this is, so you said that hocam, this profit function is going to be a function of Q according to that. So total revenue is a function of Q and total cost is a function of Q, okay? Now total revenue is basically PQ times Q minus total cost, which is a function of Q, right? So this is basically, and you see that this is very much, so this is what you can think of as the sales, right? How much Starbucks sales, right? How much Toyota sales. But that's not their profit, right? It depends heavily on their cost, how much they earn. They might be selling a lot, but it's not, it doesn't mean that they're making a lot of profit, okay? So this is basically, you know, like the case. So this is what the firm would do. They would like to maximize profit, right? Total revenue minus total cost, subject to what?
The production.
Subject to what? And then you said, hocam, they are deciding on what? What is the variable that they decide on? Q. Subject to what? Huh?
The production.
So some people say production function, but remember production function is already embedded where? In the cost function, right? It's already there. So it's here. Production technology, input prices, right? All of them, production technology, production function, input prices, they're all embedded here. So market structure, demand curve, we'll see that the firm faces, right? It's there. Any information about the market structure is embedded there. So subject to nothing, okay? So there is none. So I keep doing this. I solve this and I say you cannot solve it like this. There is no subject to, okay? So this is going to be so good, no Lagrangian, no more Lagrangian or anything. This is going to be an unconstrained optimization, okay? That's it. Of course, you guys, which is good, you guys were immediately aware of the fact that, hocam, if production technology changes, right, production function changes, these things will change here, yes. But they will change because the cost function will change, okay? So there are implicit constraints here, but the final problem that we solve is an unconstrained optimization, okay? So this is an unconstrained optimization, okay, problem. Okay, so how can we solve this? How do we solve? How do we maximize a function? What should we do? We take just the derivative, right? So, and then, so let's have that and set it equal to 0. But is it enough to say that it's the maximum? No. What should we check? The second derivative as well, right? So let's do that. So it's going to tell us something, okay? Now let's do, you see, so our life is easier. So we did the harder stuff first. Now it's much easier. Okay, so let's think of the optimization problem there. So let me actually write down the necessary condition, okay? So we take the derivative of the profit function, right? So let's actually do that. So basically, phi prime, so let's say necessary, okay? So this is the necessary condition for a maximum. So basically, so this is going to be total cost dq, okay? And we should set it equal to 0. What is this guy? When I take the derivative of the total cost function with respect to q, what did we call? We called it marginal cost, right? So this is marginal cost, right? What is this guy called? Some of your friends might not know, but it's called marginal revenue, okay? So what does that mean? It means that if Starbucks or if Toyota produces another, okay, we don't have Camry here, right? So what do we have? Bless you. Corolla. So suppose Toyota produces one more Toyota Corolla, or they sell one more Corolla. How much will that contribute to their earnings, right? So to their, you can actually think of it as to their total revenue. If I sell one more Corolla, how much extra revenue it will bring, okay, to my total revenue. So this guy is called marginal revenue, okay? Yes?
Do we assume that it sells whatever that it produces?
Of course, so this is here, it's right, so we are now, because we assume that the firm is the producer and the seller. You can think of it as Toyota, okay? Because she's right, sometimes the producer is someone else, and then, you know, like you buy the, for instance, the car from, instead of the, for instance, for the car, if you think of the automobile market, you buy it from a dealer, right? So things will change, but it's here you think that the firm is producing and selling, okay? So it's the same, but that firm, Toyota, would then be selling it to the dealer as well, okay? So you can think of the, yeah?
I didn't mean it like, I meant there are no inventories.
Yeah, so here, no, okay? So we don't have, right, whatever they, so your friend is asking, Hocam, do the firm hold any inventories and such? So here, whatever they produce, we assume that they sell, okay? If they would like to hold some as inventories, that would be a different problem, okay? Now, so this is, so what is the condition, profit maximizing condition? As you can see, it is marginal revenue should be equal to marginal cost, right? At the profit maximizing output level, marginal, basically the contribution of producing and selling that last unit of output is the same. The cost that it will bring to you should be equal to the benefit that it will bring to you, okay? So basically this is the condition. But you said that, so this is for your friends, so this is actually called marginal revenue. Okay? The contribution of producing or selling an extra unit to your total revenue. Okay? Now, but you said that, Hocam, this is not enough. We also, I don't want to erase this, but unfortunately, my beautiful masterpiece. So it's, right, but you said that, Hocam, that's not enough because this point could be the minimum point, right? So it's the, so in order to figure out the maximum, to make sure that it's the maximum one, we have to make sure that whatever Q star, so let's say, right, so whatever Q star, we can actually call it like this, is, so let's put it, it should be the case that the second, we have to check the second derivative, not right? So let's call it sufficient condition. So let's put it like this. At profit maximizing Q star, we should have this, okay? And to be maximum. Basically, as you said that hocam, we have to check the second derivative. Right? So what is this? Basically, or if you want, you can have whatever. So I need to check dq, right? I need to check this at this, whether at this q star, this should be what? So for a maximum, always think of it like this. For a maximum to exist in such a function, do you think a maximum can exist? No, right? There's a minimum here. In this function, a maximum. So this is a concave function. The other one is a convex function, right? So it has to be concave. So we know that it has, at least it should be on the concave portion, right? If it's a function that shows, you know, different stuff. Then what do we say? Less than 0, right? The condition for concavity is that it should be concave, so that optimal point you should plug it in, and then it should give you, right, the second derivative should be negative, okay? So this is basically the case. Now let me actually draw again graph. So let me draw this. But before, actually let me, because drawing it might take a little bit of time, so let me actually talk a little bit about the marginal revenue, okay? So what is marginal revenue? So suppose, let's think of this, right? So this concept that we have here. So what is marginal revenue? Marginal revenue, if I sell an additional unit, how much revenue this will bring to me, right? Now let's think of so let's have it like this. Now let's think of, suppose I'm Starbucks, okay? And I can sell whatever unit I want at a fixed price P, right? Suppose I'm Starbucks, I'm selling caramel macchiatos, okay? I can sell any caramel macchiato, you know, like any quantity at a fixed price P. This is not going to change. Then what do you think my marginal revenue? If I sell one more caramel macchiato, what would be my marginal revenue? P, right? Let's say it's 10 Turkey. How much is it? It's too expensive, right? 8, whatever, 8.50, 9. So it's right. So it's 9 Turkish liras, let's say. Okay. So it's 9 Turkish liras. So if I can sell as many caramel macchiatos as I want at 9 Turkish liras, then my marginal revenue would be P, right? But suppose, let's say this is the price of caramel macchiato. This is the quantity of caramel macchiato. Suppose Starbucks faces a demand curve for caramel macchiatos like this, okay? And suppose they're selling it at 9 Turkish liras, and then, you know, like here is the quantity, okay? I don't know, whatever that is. Let's call it Q bar, okay? So they are selling this much. Now, suppose Starbucks would like to sell a little bit more caramel macchiatos, right? Then what should they do? So everyone who is smart enough to buy a coffee at 9 Turkish liras, right? They are actually buying caramel macchiato. Don't get offended. I also buy it too, so I'm also one of the smart people. So anyway, but right, so then you go, you buy, we're all buying it, right? Now suppose they would like to sell a little bit more. What should they do? They have to decrease, right, the price. Now, then what's going to happen? Suppose Starbucks would like to sell one more caramel macchiato. Do you think they're going to sell it at a price still which is at 9? Right? You said that no, hocam, they cannot. So the previous example I gave is where the firm is a price taker, and then how much they sell, it doesn't matter. It doesn't affect the market price, okay? But that is not always the case, okay? So the firm might face a demand curve like this. Then what's going to happen? So then if the firm would like to sell a little bit more, they have to decrease the price. So you see that marginal revenue is not going to be 9. But how much do you think it would be? It's going to be, right, but we have to think, right, it's going to be, so what is the gain here for Starbucks is this additional guy, right? They're going to sell one more caramel macchiato to someone else. They're going to get some extra money. But what is the loss of Starbucks? For these guys, they were selling it at 9 Turkish liras. Now for all those guys, they have to sell it at a lower price, right? A little bit low price. They have to sell it. So they're going to lose that much, but they're going to gain that extra guy, okay? And as you guys guessed, that you said the hocam, it's going to be less than 9, right? It's not that. So this is what we were seeing it in econ in the baby micro, okay? But now, because we know the functional form and everything, we can write this. And then I'll write this and then we'll stop, okay? So DTRQ, DQ, okay? So this is the case. So if you write total revenue like this, okay? So this is DQ. If you take the derivative, what is the derivative with respect to Q? Right, so first you can actually have PQ times 1 plus, then you have DPQ, DQ times Q, right? So this is marginal revenue. Okay, so if I take this into PQ parentheses, right? So basically, it's going to be 1 plus, but let me first tell you this. What is this? DPQ, DQ. What was this? We saw this. This is the slope of the, what? This is the slope of the inverse demand curve, right? This is the slope of the demand curve. So basically, this is the slope of the demand curve, and most of the time, this has a sign of what? Negative, right? So what does this tell me? Marginal revenue is, just as you guys said, is, so this is PQ minus something. Marginal revenue is marginal revenue is less than or more than price? Less than, right? So you see that from here, you can immediately say marginal revenue is always less than price, okay? And also, what is this? So let's put this. You take this into PQ parentheses. What do you have? 1 plus DPQ, DQ, Q divided by PQ. What is this guy? What does this look like? Elasticity, or elasticity was, remember, we were X, PX. Now instead I have QP, which is perfectly fine. But here I had what? Del X, del PX, PX over X, right? So what is this? It's the 1 over elasticity, right? So you can actually write, you see that marginal revenue is equal to 1 plus, this guy is 1 over elasticity, right? So you can actually have this. You see there is this relationship between marginal revenue and elasticity, and you'll see that it's going to be very important. Because remember, the profit maximizing decision is related to marginal revenue. You see now why it is very important to know demand elasticities, because for firms, it's going to appear in their profit maximization, right? It will affect their profit maximization problem because it's embedded in the demand curve, obviously, okay? So we'll continue from here, okay, on Friday.